Hi guys, so today we are on our last method of solving quadratics, and this is the quadratic formula. Okay, so there's different histories of how it came about, but one way is some person in 7th century India was solving a lot of quadratic equations by completing the square, which we did previously. At some point, he noticed that he was always doing the exact same steps in the exact same order for every single equation. Since sometimes mathematicians were a little lazy, he derived a formula that shortcuts the whole process. Okay, we're not going to be covering how it came to be, but the proof of it will be available in this music video that I show you the next day. Okay, so this here is the quadratic formula. I'm going to show you a little music video that helps you remember it a lot. If you sing the song when we do it in class and everything, you will definitely remember the quadratic formula. Okay. So for the quadratic equation, ax squared plus bx plus c equals 0, again, has to set it equal to 0, so move everything to the same side. Okay. The zeros, roots, or solutions can be found by this formula, which is the quadratic formula. Okay. So x equals negative b plus or minus square roots b squared minus 4ac all over 2a. And yes, you have to memorize this formula. I will show you a song that helps you remember it with no problem at all, okay? So, good news about the quadratic formula. It works for all quadratics, right? Whereas factoring, it has to be factorable, right? Or completing the square, it has to be like nice and easy for some of us because b has to be even. The bad news is that while it is very easy to use and it works for everything, there's a lot of ways that we can sometimes make computational mistakes. Okay, so here we're going to solve using the quadratic formula. First of all, it has to equal 0. So what I'm going to do is I am going to move this 12 over by subtracting. Okay. So this is 3x squared minus 5x minus 12 equals 0. I couldn't combine these because they are not like terms. Okay. Now I'm going to identify all of my parts. So A, B, and C. Okay. So A equals 3, B equals negative 5, and C equals negative 12. Okay. And then all we have to do, nice and easy, plug it in. Okay, so I'm actually going to highlight some stuff for us. That way it's easier for us to see, right? So A is 3. B is negative 5 here. And C here is negative 12. Okay, so let's plug it into our formula. So X equals negative B. So B here is negative 5. So negative 5. Plus or minus square root b squared, so negative 5 squared, minus 4 times a, which is 3 times c, which is negative 12, all over 2 times a, all over 2 times a, which in this case a is 3. Okay, so nice and easy, you just plug it in, and then you just need to simplify it. This is where the difficult part comes in. You got to make sure you do it correctly. Okay, so negative 5 is positive 5, okay, plus or minus. Square root, negative 5 squared is negative 5 times negative 5, so that's 25. Okay, then negative 4 times 3 is negative 12. Negative 12 times negative 12 is 144. All over 2 times 3, which is 6. Okay. Like I said, this learning target, I am not giving you a calculator, so you got to make sure you're doing this correctly. So I would slow down, write everything, do not cut corners. Okay. So keep going. 25 plus 144 is 169. So then square root of 169, it's actually a perfect square. It's actually 13. Okay. So that means one of my answers is 5 plus 13 divided by 6. The other one is 5 minus 13 divided by 6. Okay, 5 plus 13 is 18, so this is 18 over 6, which gives me 3. Okay. 5 minus 13 is negative 8. Negative 8 over 6, negative 4/3. So my two answers is x equals 3, x equals negative 4/3. Okay, when it's nice and simple, you know what this meant? This meant that we could have probably factored this. Right? So this meant that we should have probably factored it. Okay? Because then it would have been x minus 3 and plus 4. Okay. So this answer right here, we should have factored it. This would have given us 3x plus 4 times x minus 3. Okay. But again, sometimes we just need to do the quadratic formula, right? But whenever your answers are nice and easy like this, what it meant is you should have used another method. Okay. So let's do the next one here. X squared plus 8x plus 3. Perfect. It's already in standard form. It's already equal to 0. So I'm going to set what everything equals to. A is 1, since this is a 1x squared. Okay. So A equals 1, since it is a 1x squared. B here is 8. And C is 3. All right. After doing practice with quadratic formula, you're going to wish for the other methods because this is long. Again, you are not allowed a calculator, so make sure you're doing this correctly. Okay, so now let's plug it in. So x equals negative b, so negative 8 plus or minus square root b squared, so 8 squared minus 4 times a, which is 1, times c, which is 3, all over 2 times a. Okay, so let me show where we got this. So negative b plus or minus square root b squared minus 4 times a times c, all over 2 times a. Okay, and let's simplify. Okay, so this is still negative 8. 8 squared is 64. Okay. Negative 4 times 1 is negative 4. Negative 4 times 3, so that's a negative 12. All over 2 times 1, which is 2. Okay. Keep simplifying. 64 minus 12 is 52. Okay. 52 is actually 4 times 13. Okay. So this is where our simplifying radicals comes back, right? So 52, if I look at my perfect squares, which one is divisible into it? That is 4. Okay. And so this is negative 8 plus or minus. That square root of 4 is going to come out as a 2. Okay. And then over 2. Okay. Then I'm going to divide. So since negative 8 and 2 are both divisible, negative 8 divided by 2 is negative 4 plus or minus. 2 divided by 2 is 1, so 1 times square root of 13. Okay. This is inside a square root, so we do not divide it by what's outside. Okay, so that's it. This is my final answer. Okay, there's two answers. One is negative 4 plus square root of 13. The other one is negative 4 minus square root of 13. Okay. And then let's do another one. Okay. So here, we're going to subtract 9, right? Because in order to use a quadratic formula, it has to equal 0. So negative x squared plus 6x minus 9 equals 0. Now that it equals 0, I'm going to set my a, b, and c. Okay. A is negative 1, since this is a negative 1x squared. B is 6, and C here is negative 9. Okay, and then plug it into the quadratic formula. Okay, so x equals negative b, negative 6, plus or minus square root b squared, so 6 squared, minus 4 times a, which is negative 1, times c, which is negative 9, all over 2 times a, which is negative 1. Okay. And let's simplify. Okay, so negative 6 plus or minus 6 squared is 36. Negative 4 times negative 1 is positive 4. Positive 4 times negative 9 is negative 36. And then 2 times negative 1 is negative 2. Okay. 36 minus 36 is 0. Square root of 0 is 0. So that just means there's nothing. It's just negative 6 over negative 2, which we know is 3. So there's only one solution here. X equals 3. Okay, let's do one more here. And then after that, we're going to figure out how can we use the quadratic formula to find out how many solutions we have. Okay, so it already equals 0. Nice and easy then. Let's find A, B, and C. Okay. A equals 3. B equals 4. And C equals 2. Now let's plug in. Okay, so X equals negative B, so negative 4, plus or minus square root B squared, so 4 squared, minus 4 times A, which is 3, times C, which is 2, all over 2 times A. Right, so I think by now we're like, oh my goodness, this is taking a long time. And that's true. The great thing about quadratic formula is it works for like everything, all of our quadratics. The bad part is it takes a long time, okay? And like I said, no calculator. Okay, so let's simplify. Negative 4 plus or minus 4 squared is 16. Negative 4 times 3 is negative 12. Negative 12 times 2 is negative 24. And then 2 times 3 is 6. Okay, 16 minus 24 is negative 8. Oh, look, we have a negative inside a square root. Right. And so what I'm going to do is I'm going to put my imaginary number there. Okay, so to deal with a negative inside the square root, it's going to come out as I. Okay. Then, because square root of 8 has a perfect square in it, it has the perfect square of 4. Negative 4 plus or minus 2i square root of 2. Okay. The reason why is because 8 is 4 times 2, so that square root of 4 comes out as that 2 here. And then if you think negative 4, the 2, and the 6, they are all divisible by 2, so it's going to be here negative 4 6 is negative 2/3. Plus or minus 2 over 6 is 1, so 1i square root of 2 over 3. And this is your final answer. Okay, so here we saw 2 real solutions, 1 real solution, and here 2 imaginary solutions. So how does the quadratic formula help us discover that? Okay, that is in the part where we have b squared minus 4ac. So what we have inside that square root in our quadratic formula, right? So b squared minus 4ac, that is what's inside our square root. This determines how many solutions we have, right? This is known as the discriminant, right? And so what we realize is that when b squared minus 4ac is a positive number, right? What we have in the square root when it's a positive. So for instance here when it was a positive 169, or here when it was a positive 52, what we realize is we end up with 2 real solutions. Right? So this one is negative 4 plus square root of 13 and negative 4 minus square root of 13. So when our discriminant, the thing inside that square root, is positive, we end up with two real solutions. When b squared minus 4ac equals 0, like it did here, right? Because of that, square root of 0 is just 0, and there's no need to plus 0 or subtract 0. It doesn't do anything. What we end up having is one real solution, right? Like we do here. Right? There is only one solution here. Okay? And then, when b squared minus 4ac, the thing inside our square root, when it is a negative, like it is right here, what ends up happening is we have no real solution. Instead, we have two imaginary ones. One with a plus I, the other one with minus I. Okay? And so that's it for today. This is the quadratic formula. Have a great rest of the day. Bye, guys.